Hello friends, welcome to my new data structures and algorithm in Java tutorial series video. Friends, in this tutorial we will discuss iterative in-order traversal of a binary tree in Java. So friends, in my previous tutorial we discussed about the recursive in-order tree traversal. So steps involved in in-order tree traversal are as follows. That before visiting any particular node, we first visit its left subtree, then we actually visit the node, and then we visit its right subtree. And this steps is applied over each and every node. So friends, if we apply in-order tree traversal over this tree, then what we need to do is before visiting the node 1, we have to actually traverse its left subtree, then we have to visit the node, and after visiting the node we have to traverse its right subtree. So when we start with the node 1, we have to go to its left subtree first, because as we go to its left subtree, there is no way we can reach to the node 1 again. Therefore, we need an additional data structure which can hold this node, so that once we complete the visiting of left subtree, we can pull the element out of that additional data structure and we can visit it. And after visiting it, we can go to its right subtree. So the additional data structure that we use here is stack. So here you can see we are using stack, which is a LIFO data structure, which means that element inserted last into the stack would be the first one to be removed. In order to know more about the stack, you can watch my previous tutorials. Before visiting this node, we actually put it on the stack and then we go to its left subtree. And this we do for each and every node. And once we actually visit the left subtree of any node, then we pop the element out of the stack, we visit that node and then we go to its right subtree. So let's see the demonstration of this algorithm step by step. So let's suppose we are given with a binary tree having 6 nodes and where root is pointing to the node 1. So let's apply this algorithm over this binary tree and let's see how we can traverse each and every node of a binary tree using the in-order tree traversal. So basically in the first step we check whether root is equal to null or not. So if root is equal to null, we simply return because there are no nodes in the tree to be traversed. So currently you see root is pointing to node 1, therefore it's not null. So the condition in if block comes out to be false. So after the if block, what we actually do is we actually create a stack. Now this stack will hold the tree nodes for us. So it would look something like this. Moving ahead. So in the next step what we do is we create a temporary tree node and we assign the value of root to it. So now the temp will point to root. So it would look something like this. That is, temporary node is pointing to root. Moving ahead. So friends, in order to traverse this binary tree using in-order tree traversal, we actually use a while loop, and inside this while loop we are actually placing two conditions. So we are iterating this while loop till stack is empty and temp becomes null. So currently you can see stack is empty. So the condition comes out to be false. But you can also see the temp is actually pointing to a node, therefore it's not null. So the second condition comes out to be true. And as there is an OR operator between these two conditions, therefore the overall condition comes out to be true. So the while loop executes. So in the while loop we actually encounter an if else block. So in the if block we check whether temp is equal to null or not. So currently you can see temp is pointing to the node 1, therefore it's not null. So the condition in if block comes out to be true. So in the if block the first step we do is we actually push the temporary node on the stack. Which makes sense because before visiting this node we have to first visit its left subtree. So therefore we are actually pushing this temporary node on the stack, so that once we are done with the left subtree, then we can pop this element out and then we can visit this node, and after visiting this node we can go to its right subtree. So when we push the temporary node on the stack, it looks something like this, that now node 1 is on the stack. Moving ahead, and in the next step we simply traverse the temp to its left, because we have to first visit the left subtree. Therefore we need to traverse temp to its left. So we are assigning the value of temp dot left to temp. So here temp left is the node 2. Therefore now temp will point to the node 2. So it would look something like this. The temp is now pointing to the node 2. Moving ahead. In the while loop, we'll again check whether stack is empty or not, and then we'll check whether temp is pointing to null or not. So currently you can see stack is not empty and temp is pointing to the node 2, therefore it's not null. So the condition in while block comes out to be true. And then in the if block we will check whether temp is equal to null or not. So here you can see temp is pointing to the node 2, therefore it's not null. So the condition in if block comes out to be true. And then we'll simply push that node 2 on the stack, because before visiting the node 2 we have to first visit its left subtree completely. Therefore we'll push the node 2 on the stack. So it would look something like this, that now node 2 is on the stack, and then we'll simply traverse temp node to its left, which is the node 4. So it would look something like this. Now temp is pointing to the node 4. And then again in the while block we'll check whether stack is empty or not and temp is equal to null or not. So currently stack is not empty and temp is pointing to the node 4. So therefore the condition in while block comes out to be true. And then in if block we'll check whether temp is equal to null or not. So currently temp is pointing to node 4, therefore it's not equal to null. So the condition in if block comes out to be true. So then in the first step what we do is we simply push the temp on the stack, because before visiting the node 4 we have to first traverse its left subtree completely. Therefore we are pushing the node 4 on the stack. So it would look something like this. Now node 4 is on the stack. Moving ahead. And in the next step we'll simply traverse temp by assigning temp.left value to temp. Which makes sense because before visiting this node we have to first visit its left subtree. Therefore now temp has to move to its left subtree. So now temp will point to a node which is left to node 4, and here you can see it is pointing to null. So therefore now temp will point to null. Moving ahead. We'll again check whether stack is empty or not and temp is equal to null or not. So currently you can see temp is equal to null but stack is not empty. Therefore the condition in while block comes out to be true. And then in the if block we'll check whether temp is equal to null or not. So here you can see temp is equal to null. Therefore the condition in if block comes out to be false. So the else block will be executed. And here we can see that node 4 left is pointing to null. Therefore there is no node to be visited. So therefore we have visited its left subtree completely. So now is the turn that we can visit the node 4. So in order to do that we'll simply pop the first element from the stack and we'll assign the temp to that node. So here you can see as stack is a LIFO data structure. So the last element inserted is the first one to be removed. So when we do a pop, the node 4 will be popped out and value of node 4 will be assigned to temp. So therefore once the node 4 is popped out, temp will now point to the node 4. So it would look something like this, that now node 4 is popped out and whatever the value it holds, it will be assigned to temp. So now temp will point to the node 4. So it would look something like this. Moving ahead. So here for the node 4 we have visited its left subtree completely. So now is the time to visit the node 4. So on the console we are simply printing the data associated with the temporary node. So here node 4 becomes the first node to be traversed. So on the output 4 will be printed. Moving ahead. And as we have visited a node 4, now we'll simply traverse to its right subtree. So we are simply assigning value of temp.right to temp. So here temp.right is pointing to null. So therefore now temp will point to null. Moving ahead. So in the while block we'll check whether stack is empty or not. So currently stack is not empty and temp is equal to null or not. So currently temp is equal to null but stack is not empty. Therefore the condition in while block comes out to be true. And we'll check whether temp is equal to null or not. So currently temp is equal to null. Therefore condition in if block comes out to be false. And the else block will be executed. So here you can see for the node 4, as its left is pointing to null and its right is pointing to null, it means there are no nodes on the left and the right side for the node 4 to be traversed. Therefore, for the node 2 we have completely visited its left subtree because we have printed the output 4, which means we have traversed this node. So here what we are doing is we are again popping the element from the stack and we are assigning it to temp. So when we pop an element from the stack, we know that it's node 2. So it would look something like this. That node 2 is popped out and its value will be assigned to temp. So it means now temp will point to node 2. And which makes sense because we have completely traversed the left subtree for the node 2. So now it's the time to traverse the node 2. So in the next step, we'll simply print the data associated with the temporary node, which is 2. So on the console, we simply print 2. And then we'll simply traverse temp to its right. So here as we have visited the left subtree for the node 2 and we also visited the node 2, now is the time we go to its right subtree. Therefore we are simply assigning temp.right value to temp. So it would look something like this. So now temp is pointing to the node 5 because it is on the right of the node 2. Moving ahead. Now in the while loop we'll check whether stack is empty or not. So currently stack is not empty and temp is also pointing to node 5. Therefore the condition in while block comes out to be true. And then in if block we'll check whether temp is equal to null or not. So currently temp is not equal to null because it is pointing to the node 5. Therefore the condition in if block comes out to be true. So what we do is we simply push the node 5 on the stack because we cannot visit this node till we visit its left subtree completely. Therefore we need a way to store this element on the stack. So we are simply pushing the temporary node on the stack. So now node 5 is on the stack. And then we simply go to its left because we need to traverse its left first. So now temp is pointing to null. In the while block we will check whether stack is empty or not. So stack is not empty but temp is pointing to null. So the overall condition comes out to be true. So the while block executes. In the if block we'll check whether temp is equal to null or not. So temp is equal to null. Therefore the condition in if block comes out to be false. And the else block will be executed. So as node 5 has no left subtree, therefore it simply means that we have visited its left part. Now we'll actually visit the node. So we simply pop the element from the stack. So when we pop the element from the stack, we know that 5 was inserted last. Therefore it would be first one to be removed. And when we remove the node 5, we assign its value to temp. So now temp will point to the node 5. So it would look something like this. So now temp is pointing to the node 5. And then we'll simply visit the node 5. So on the console we print the data associated with the temporary node, which is 5. Moving ahead. And once we have visited this node, now it's the time to go to its right subtree. So now temp will point to null. Moving ahead. In the while block we'll check whether stack is empty or not. So currently stack is not empty but temp is pointing to null. So the overall condition comes out to be true because stack is not empty. So the while block executes. In the if block, we'll check whether temp is equal to null or not. So temp is equal to null. Therefore, the condition in if block comes out to be false, and the else block will be executed. So here you can see we have completely visited the node 5, and this node 5 is actually right to the node 2. Therefore, we have completely visited the left subtree for the node 1. So when we pop an element from the stack, 1 gets popped out, and now temp will actually point to the node 1. So node 1 is popped out and its value will be assigned to temp. So now temp will point to node 1. Moving ahead. So friends, here you can see for the node 1 we have completely visited its left subtree by printing 4, 2 and 5. So now we can actually visit this node. So therefore we simply print the data associated with this temporary node, which is 1. So 1 gets printed on the console. Therefore we have visited this node. And the next step, as we have visited this node, now we'll simply go to its right subtree. Therefore we simply assign temp right to temp. So here you can see temp right is pointing to the node 3. Therefore now temp will point to the node 3. Again in the while block we'll check whether stack is empty or not. So here you can see stack is empty. So the first condition comes out to be false. But here you can see temp is pointing to the node 3. Therefore it's not equal to null. So the second condition comes out to be true. So here the overall condition comes out to be true and the while block executes. So here we will check whether temp is equal to null or not. So currently temp is pointing to the node 3, therefore it's not equal to null. So the condition in if block comes out to be true. And here before visiting the node 3, we have to first visit its left subtree completely. Therefore we need a way to store this element on the stack. So we simply push the temporary node on the stack. So it would look something like this. Now 3 is on the stack. And then we'll simply go to its left subtree, because this left subtree we need to visit first before actually visiting the node 3. So we are simply assigning temp.left value to temp. So here you can see temp left is pointing to the node 6. So therefore now temp will point to the node 6. In the while block we'll again check whether stack is empty or not. So currently stack is not empty. So the first condition comes out to be true and temp is actually pointing to the node 6. Therefore the second condition also comes out to be true. So the overall condition comes out to be true and while block executes. So in the first step we'll check whether temp is equal to null or not. So currently temp is pointing to node 6, therefore it's not equal to null. So the condition in if block comes out to be true. And then we'll simply push the node 6 on the stack, because we can't visit this node till we process its left subtree completely. Therefore we are storing the node 6 on the stack. So after pushing the node 6 on the stack, we simply go to its left subtree. So now temp will point to the left of the node 6, which is null. Moving ahead. Now currently stack is not empty, but temp is pointing to null. Therefore the overall condition comes out to be true. We check whether temp is equal to null or not. So temp is equal to null, therefore condition in if block comes out to be false and the else block will be executed. So here as node 6 has node left subtree, therefore we are done with the processing of the left subtree for the node 6. So now is the time that we can visit the node 6. So what we do is we simply pop the element from the stack, because we know that we have actually stored this element on the stack. So we pop this element from the stack and we'll assign it to temp. So it would look something like this. So now temp is pointing to the node 6. Moving ahead. And then we are simply printing the data associated with node 6. So 6 gets printed on the console. And as we have visited this node, now is the time to go to this right subtree. So therefore now temp will point to null. So in the while block we'll check whether stack is empty or not. So currently stack is not empty. So this condition comes out to be true. But temp is pointing to null. So the overall condition comes out to be true. So the while block executes. We check whether temp is equal to null or not. So here temp is equal to null. Therefore the condition in if block comes out to be false. So the else block will be executed. So friends, here you can see for the node 6 we have actually visited its left subtree, we have visited the node, and we have visited its right subtree. So therefore we have completely visited his node 6, and here you can see node 6 is to the left of node 3. So now you actually traverse the left subtree for the node 3. So therefore now we can visit the node 3. So in order to reach to node 3, we know that we have already stored this node on the stack. So we simply pop this element from the stack and we'll assign it to temporary node. So it would look something like this. That node 3 gets popped out and its value is assigned to temp. So therefore now temp will point to node 3. And then we'll simply print the value associated with this temporary node, which is actually 3. So 3 gets printed on the console. And as we have visited the node 3 completely, now we need to visit the right subtree. Therefore we are simply assigning temp right to temp. So now temp will actually point to null. So now again we'll check the condition in while loop. So first we check whether stack is empty or not. So currently stack is empty. So the first condition comes out to be false. And then we'll check whether temp is equal to null or not. So here you can see temp is equal to null. Therefore the second condition comes out to be false. So overall both the conditions are coming out to be false. So the while loop terminates. And here you can see we have actually visited all the nodes of this binary tree. And we have printed the data associated with those nodes, which is 4, 2, 5, 1, 6, 3. So friend, this was a demonstration of the algorithm. Now let's go to Eclipse and see the working code. So friends, in my previous tutorial, we actually created one class by name binary tree, and we actually implemented the binary tree into this class. So friends, in order to understand binary tree more, you can watch my previous tutorials. So in my last tutorial, we actually discussed the recursive version of the in-order tree traversal. But in this tutorial, we will discuss the iterative way for the in-order tree traversal. So here I will just comment this code, and below I will create the method as in order. Now this in order method will take in a root. So let's code the algorithm which we saw in the slide. So in the first step we'll check that whether root is equal to null or not. So if root is equal to null, we'll simply return from this method because there are no nodes in the binary tree to be traversed. And the first step will create a stack which will hold the tree nodes for us. And as we discussed in the slide, we'll create a temporary node and we'll start it from the root. So tree node temp, and we'll simply assign the value of root to it. And now we'll simply provide a while loop. And we also saw that we have placed two conditions on that whether stack is empty or not. So the first condition is we are checking whether stack is empty or not, and then we are providing an OR. And the second condition we provide is temp should not be equal to null. So in the while loop, we'll simply provide an if else block. So in the if block, we'll first provide a condition that temp should not be equal to null. And if temp is not equal to null, then we simply push the temp on the stack. And then we traverse temp to its left. And if temp is equal to null, then we simply pop an element from the stack and we will assign its value to the temporary node. Once we pop the element from the stack, we'll simply print it on the console. So temp dot data, and as we have printed the data on the console, then we'll simply traverse temp to its right. So friend, this is the code for iterative in-order tree traversal. Now let's test its working in the main method. So here first we have initialized the binary tree, and then we have created a binary tree with few nodes. So here in create binary tree, we have actually created few nodes, which we also discussed in our previous tutorials. You can watch my previous tutorial in order to understand how this binary tree is created. And after creating the binary tree with few nodes, we'll simply call the in-order method and we'll pass the root to that method. So if I run this code now, so here you can see it prints 4293, because in the create binary tree the root is 9 and root left is second, which is 2, and root's right, which is 3. So here 9 left is 2 and 9 right is 3, and here you can see second left is 4th. Now the fourth node is pointing to the second's left. So 9 is at the root, its left is 2 and its left is 4. So therefore, so on the console it printed 4, then it printed 2, and then 9 and then 3. Because as 9 is on the root, in order to process this node, we have to first visit its left subtree. So on its left is the node 2, and before processing the node 2, we have to go to its left subtree, so which is 4. So 4 gets printed first, then we print the node 2, and then we actually print the root node, and then we go to its right subtree, so we simply print 3. So friends, in this tutorial we discuss the iterative version of the in-order tree traversal. I hope you liked this video. Please like, comment, share and subscribe my YouTube channel. Thanks, have a nice day.